Sometimes when you're doing this, a two-way table is a great way to model this. In our example, we have students in a college stats class that want to find out how common it is for young adults to have their ears pierced. They recorded the data on two different variables: gender, so male and female, and whether or not their ears were pierced. For all 178 people in the class, and here is a table below. And so suppose that we choose a student from random. At random from the group, the 178 students. What's the likelihood that this happens? So we look for the pierced ears, and so when we look for the probability of the pierced ears, we'd say the probability of pierced ears is equal to, and we know that the total sample space is however many students were surveyed or looked at, so that's 178 for the total. And then we look for all the ones that were pierced. So all the pierced, male and female combined, were 103. So our probability is 103 out of 178. Bless you. If we're looking for the male with pierced ears, so I'm just going to abbreviate male with pierced. We still know that our sample space is 178 students that were surveyed, but now we're looking for the males with pierced, which was a total of 19. So the probability that you find out of all 178 people, the males with the pierced ears, there are only 19 of them out of the 178. And then you look for the probability that you have the male or pierced ears. And our sample space is still the 178. So now I want the male or the pierced. And so when I want male or pierced, all the males combined are 90, and the pierced are 103. But if I add those two things together, that gives me 193. So I don't want that. I want all the males, and then all the females that were pierced. So I add those two up together, and that's a total of 174. So be careful that you don't overlap with something that you already have recorded. Okay, so in this example, we see that the or can be interpreted two different ways. One, it means either A or B, or both, but in real life, sometimes it just means the A or the B. So in number two, since we're dealing with two events that are not mutually exclusive, for example, you can have overlap between the two, we look for what outcomes they share and also take that into account. So down below we have something called a Venn diagram. In general, Venn diagrams have a rectangle, and then within the rectangle, every event is represented by a circle. If they do overlap, the two circles, meaning that the two events could occur at the same time, the circles will overlap, and that's what they share in common, which means that they're not mutually exclusive, which is what we were talking about earlier. So on the left here, at the top it says, these outcomes here are double counted when you add probability A and B. So on the left, if I have the first circle being probability of A happening and the right is probability of B happening, you'll notice that in the middle here, this space is counted twice. Because if I look at the yellow circle, I've counted the stuff in the red shading. And if I look at the blue circle, I've done it again. So if they're not mutually exclusive, you have to take that into consideration and subtract that out. That's what's going on right here. This is the subtraction out of the overlapping, or the part that they share in common. And then on the left, the probability over here, they're talking about the probability of being a male. That's 90 people out of the 178. On the left, this is the probability of having pierced ears, which was the 103 out of 178. And the overlap is the fact that you have some males with piercing. That's the red shaded part. So that was a double count, and that's why we subtracted out. Does that make sense to you guys? Okay. So down below, this is the rule. If two events are not mutually exclusive and you use the word or, the probability of A or B occurring, you add the two probabilities, but then you have to subtract out their overlap, otherwise you've counted it twice. And that's what this formula down at the bottom is saying. In this next slide, they're just trying to explain what you see and what it means. So in the first slide, they're demonstrating how you can see that in a sample space, in the square that you see that's green, It's the whole sample space, including the circle, the probability of event A. So if we were talking about the probability of event A being the white circle, the green is its complement, or means everything but the probability of A occurring. Again, you could do the probability of A and go 1 minus it to find that complement. In sample space on the right-hand side at the top, we see that there are two events, A and B. These two events are mutually exclusive, means they can't happen at the same time, kind of like getting the sum of 5 in the yellow circle and getting a sum of 6 in the blue circle when you roll the two dice. And then the sample space, of course, would also include everything else outside the circles that could occur, like the sum of 2, 12, 11, 7, all that kind of stuff. Down below, on the left-hand side, we see the two events that are not mutually exclusive. So this could be like the males on the left, the piercings on the right, and then the shaded region in the middle is where they overlap, meaning males that have pierced ears. And the union, so this intersection symbol here that you see was representing that. I probably should have pointed that out. So this symbol means intersection, or in other words, where do they overlap? That's what it's talking about. And union means everything together. So the union on the right-hand side here, this U symbol, it's not a U, but it's a union symbol, means look at the two events and tell me the total of everything. That's what the word union means, and that's what the symbol is. Questions about either of those symbols?
What is the upside down one?
The upside down one is intersection, and the right side up U is union. Intersection means overlap, union means everything together. Carly?
Can you use the word disjoint to describe it?
No. In this case, you cannot use the word disjoint because the circles are not separate. So disjoint is the example back up here on the right-hand side where the two circles are not overlapping. You still could talk about the union of the two and the intersection if you want to, but this picture on the top right is a disjoint picture, and you still can use intersection and union. So for example, if I said, what's the intersection of A and B, you would say 0. The probability is 0. It can't happen. But if I talked about the probability of those two things and I told you that the probability of A occurring was 0.2 and the probability of B was 0.3, I would say the probability of their union is 0.5. Okay? Because they are disjoint. Down below we have a picture here representing the information we talked about a little bit earlier about with pierced ears. So in the A, I believe that they're talking about all of the males. So this was males. And in B, they're talking about, I believe, all the piercings that occurred. And so in the stuff down below here, they are talking about all the different things that you could maybe be asked in a question. So for example, down below here they say, in the intersection of our two circles, right here, where you see this 19, they are talking about the males and the pierced ears, which they represent with A intersection B. How many people were in there? 19. So if we talk about the probability of that occurring, that's how we got the 19 out of whatever the sample space was. In the second example, they are talking about what is the probability, or how many people are both being male but not having their ears pierced. That's this thing right here. Notice how they represent it. Males is A, and is the intersection symbol, and not pierced is the B with the complement. So the C means not. And they're talking about the space over here. Here are the males that don't have pierced ears. There are 71 of them. In the next group, they're talking about what happens when we're talking about females with pierced ears. And that's all the other people who had pierced ears but weren't males. And that's why it's 84. Notice how they represent it. So it's A complement, which means the males that were, the not males, no males, and female pierced. Okay, so intersection means and, complement means not. And then the last one is talking about outside both circles, which means you're female and you don't have any piercings. And so when they represent that, the A complement means not a male, and the B complement means female without piercing. And that's everything that was not talked about already in that space. So everything outside the circles is what they're talking about. The most curious thing, of course, is the symbology that they use, which is very important because when you take your test, they're going to use those symbols to represent what's going on in the sample space. So you have to understand what the word complement means, what the intersection symbol means, and what the union symbol means. Remember, intersection means and it's the overlap in the circles. The union means put everything together, add them up, and it's used with the word or.